Okay, here are the solutions for page 13. First, this problem says, find the equation of the tangent to the curve at y equals, open parentheses, x minus 4, close parentheses, squared, at the point where x equals 5. This doesn't really look any different than the other problems we've been doing easily with the calculator. If we did have to take the derivative, might be a challenging new derivative because we need to expand it in order to take the derivative first, because we don't know how to take the derivative of x minus 4 times x minus 4. But we don't really need to, because basically they're giving us the x value, they're asking for the tangent, and they're giving us the function. So we already know how to do that. We just, like we did last class, we go to y1, and we program in the function itself, which is x minus 4 squared. And then we graph it. And then we do second draw tangent. Second draw tangent, which is number 5. And then we type in x equals 5, or we just type 5. And then it draws it, and it gives us the equation. Y equals 2x plus negative 9, which is the same thing as y equals 2x minus 9. That's it. Okay, let's move on to the next one and see how they can make it more difficult. Find the equations of the tangents to the curve, wow, more than one tangent, y equals 3x squared minus 2x at the points where y equals 8. What is difficult about this problem that's not difficult about problem 1? Well, in problem 1, they gave us x, so we could go directly to second draw tangent and type in the x value. Here we don't know the x value. Okay? So since we don't really know what we're doing yet, na dúvida, we're going to take our first function and we're going to program that into y1. Okay? Into the blue function. Then we're going to take the derivative function, we're going to put that in y2. So our y2 is going to be y dash equals 3 times 2x to the first minus 2. And we're going to simplify that. It becomes 6x minus 2. Y dash equals 6x minus 2. So what we're going to do now is we're going to put both of these into the calculator. The blue function is going to be the original function, which is 3x squared minus 2, minus 2x. And then the red function, which is the derivative function, is going to be 6x minus 2. And I'm not going to graph it. I'm just going to go to the table and see if I can answer the question now. The question asks, find the equation of the tangents to the curve, the blue curve, at the points where y equals 8. So I want to know when the blue curve has y equals 8. Where should I look for that? I should look in the blue column because this is y, right? What's y2? y2 is the gradient, so it's not the gradient, they're talking about the y-coordinate, okay? So I already see one value of blue 8 here. I don't see any other values of blue 8 here. It's just getting bigger. Maybe it's a little bit above. We'll go back a little bit. I don't see any value for 8 here either. It looks like it would be between x equals negative 2 and x equals negative 1 because it would be between blue 16 and blue 5, right? So what if I increased the gap here, the step size? So instead of 1, I'm going to jump by 0.5. So, oops. So I'm going to put 0.5, see if that's enough. And not quite, right? Now I'm going to increase it to plus 0.1. Can I see it now? Almost. Look, there. Plus 0.01. Okay, there we go. So it looks like negative 1.33. Okay? So one of my points is going to be, one of my x values is going to be negative 1.34, comma 8, right? And the other one is going to be down there. So I changed the step size back to 1 again. And now I'm going to check. And the other value of 8 was at 2, comma 8. So those are the 2 points which have, which they're asking for. And now we want to know the equation of the tangents at each of those points. So now that we know the x values, which are negative 1.34 and 2, I can go back and do second draw tangent again, right? So I'm going to go graph, and then I'm going to do second draw tangent, number 5, and I'm going to put in negative 1.3. I think it was a negative 1.33 or negative 1.34. I think it was negative 1.33. Okay, so I'm going to change this to 3,3. So this tangent would be y equals negative 9.98x minus 5.3067. Okay? And then the other tangent at x equals 2, I find the same way. I do second draw tangent, which is number 5, and then I type in x equals 2. Okay, and this one is going to be y equals 10x minus 12. Okay? This one is going to be 5, it's 0.3. Okay? All right, let's go to the next one. Find the value of x for which the gradient of the tangent to the curve is y equals parentheses 4x minus 3 quantity squared is 0. So I'm not sure about this one either. So what I'm going to do is I'm going to find the red function. The blue function is this function there. And I'm going to take the derivative of it. Remember that to take the derivative of something multiplied together, I need to expand it first. So I'm going to do FOIL. 16x squared minus 12x minus 12x plus 9. 16x squared minus 24x plus 9. That is my blue function. Sorry, I wrote it in red. Now I'm going to take the derivative. It's going to be 2 times 16, which is 32, x to the first, which is just x, minus 24, because the derivative of 24x is 24. Now I have my red function, and I have my blue function, and I'm going to put those into the calculator. Okay, and I'll do that, and I'll be right back. Okay, so I put the blue function there, I put the red function there. Remember, when I do this, I don't go to graph, I go to the table. And I am going to look for when the gradient of the tangent to the curve is 0. The gradient of the tangent, remember, is synonymous with the derivative. Gradient, slope, derivative, all the same thing. So we're looking for the derivative. So derivative is red. We're going to try to find the red 0. I don't see any red zeros, but it looks like if there was a 0, it would be between 8 and negative 24. So why don't we go between 8 and negative 24, and we'll change the step size to 0.1 and see if we can find it. We're looking for 0, remember? Ooh, it looks like it would be between these two. So I'm going to do plus 0.01. There it is. So the answer is 0.75 would be the x value, and 0 would be the y value. So it says find the value of x for which the gradient of the tangent of the curve is 0. It's going to be 0.75, right? That's 8. B, find the equation of the tangent at this point. Okay, so this, we know now the x value is 0.75. So what we could do is we could do second draw tangent with x equals 0.75, right? So we're going to do that. Second draw tangent. Second draw. Hello. Let's try that again. Graph. Second draw tangent number 5. And then we're going to type in 0.75. Enter. Wow, it's a perfectly flat tangent. And this the formula is y equals 0x plus 0, or y equals 0. It's a flat line. Okay? So that is the equation of the tangent. Let's go to number 13. Find the value of x for which the gradient of the tangent to the curve, blah, 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 there's the blue function, is 16. Okay, so let's do that. First, what we're going to need to do is we're going to need to find the derivative of the blue function. Y dash is equal to 4. And then, this here is equal to 4x plus 3x to the negative 4th, right? That's our blue function. So our red function, the derivative, is going to be 4 plus 3 times negative 4x to the negative 5, because negative 5 is 1 less than negative 4. Then I'm going to rewrite this. Y dash equals 4 minus 12x to the negative 5. Then I'm going to see when is this expression equal to 16. The way I do that is the way we've always been doing it. We're going to go to y equals, and I'm going to put the blue function here and the red function here, and then we're going to check the table, okay? So I'll be right back. So it looks like this is typed in correctly. 4x plus 3x to the negative 4. 4 minus 12x to the negative 5. We're going to go to the table, not to the graph. And then, I can change my my step size back to 1 for now. Sorry. Second table set. Change the table start to 0. Second table. And then I'm going to find the equation of the tangent at which point? At this point where the gradient of the tangent is 16, which means red 16. Okay, so let's find when the red number is 16. I think I just hit an asymptote. So do you see how the red number is like always 4? So let's go back and see if we can find a place where it might be 16. Oh, there it is. Okay, there's 16. All right. So the point where the gradient of the tangent is 16 is, negative 1, comma, negative 1. And they want to know the tangent at this point. The way I would find the tangent would be second calc. Not second calc. Second draw tangent. And I'm going to put negative, we got to go into graph first, okay? Graph, okay. Now I do, we got to wait for it to graph now. Okay. Second, oh my gosh. Just so that we don't get confused on this, I am going to turn off the red function by clicking on the equal sign here, okay? All right, now it'll only graph the blue function, and we can do second draw tangent on the blue function. I'm going to do second draw tangent, x equals negative 1, okay? Second draw tangent, negative 1. Okay, and the equation is y equals 16 plus 16x plus 15. Okay, so that's the tangent line. Then they ask for the normal line. The normal line, this is much more difficult because we can't use second draw tangent. We must use the point slope form formula. So first of all, take a look at that. This is a way of writing the equation of a line if you know a point, x1, y1, and you know the slope m. Okay, so let's use this. We know that the normal line, which is basically the line that's perpendicular to the tangent line at that point, it goes through the point -1, -1, and it's perpendicular to this slope here. The slope here is 16. What is the perpendicular to 16? The perpendicular to m equals 16 is the negative reciprocal of 16, which would be -1 over 16. So this would be the slope for your normal line. So first what I'm going to do is I'm going to write the equation for point slope form. And then I'm going to fill in the yellow numbers with, I'm going to fill in the yellow numbers with -1, -1. So I'm going to put y minus -1 equals slope, which happens to be -1 over 16, x minus -1. Now, if I have two negatives in a row, that's positive, so I'm going to rewrite this in a nicer way. Y plus 1 equals -1/16, x plus 1. Okay? And this could be the equation of the normal line. They didn't ask it in a specific form, so this is fine. Okay? If they say, oh, it needs to be in standard form or it needs to be in slope-intercept form, then you would need to do algebra on it, expand it, combine like terms, etc. But they didn't ask for that, so there's the normal line right there. Okay? That is part C. Let's look at number 17. The gradient of the tangent to the curve kx squared minus 2x plus 3 at the point 4, b is 2. Find the value of k and that of b. Okay, this is a pretty hard problem also. Okay, this is my function, and normally what we do with the function is we immediately put it into the calculator to graph it or to look at the table. Now in this particular case, we can't because there's a variable k there, right? Right in the middle of the thing. Okay, so we can go ahead and take the derivative though, because even if there's a k there, we can treat it like a number. If I have 3x squared, what is the derivative of 3x squared? It would be 3 times 2, x to the first. So I can just leave k there, like we usually do, and then I bring down the 2, and then the x, instead of being x squared, it's going to be x to the first. Negative 2x is going to be minus 2, and derivative of 3 is just 0. So my new derivative is 2kx minus 2, where we don't know what k is. Okay, let's see if that helps. Then it says the gradient of the tangent to the curve at the point 4, b is 2. So we know that this derivative is equal to 2, and we know it's 2 at, what is that? Is that x or y? It's x, right? At x equals 4 and y equals b, we don't know what y is, we know that the derivative is 2. So if we know that the derivative is 2, and we know that x is 4, we could fill in everything, and we end up with an algebraic equation. We could write 2 equals 8k minus 2. We add 2 to both sides. It gives me 8k equals 4. And then we divide both sides by 8. We get k equals 4 divided by 8, which is 1/2, but you could just like leave 4/8 if you want to. So that's the value of k. So we know the value of k now. If we know the value of k, can we now figure out the value for b? Let's see. So for k, we're going to put in 4/8. And now we have the function. And now they want the value for b. What's the value for b? b is the y value that corresponds to x equals 4. Now what you could do is, now we have the function, we can plug it into the calculator, and then we can find out. We could find out what b is just using table. Okay, so I'm going to type this in. I'll be right back. 0.5x squared minus 2x plus 3. Now I'm going to look at the table, and I'm going to see what the value of b would be at x equals 4. It would be 3. So 4 comma 3. So that's b, and that's k. All right, and that's it for page 14. We're done with page 13 and 14.